We're going to be talking about some trig identities. You will see a big list of identities at the top of your notes. We're going to do our first couple examples before we talk about those. In our first two examples, we are going to be looking at a whole lot of review material here. The question is presented different than we saw it before, but there's no new information we need to solve this. We just need to approach this problem differently. So the first thing we want to do is start drawing an angle. And we are told that that angle should be between pi halves and pi. So what does that mean about where this angle should be? Which quadrant should we draw that angle in? The second one. Because pi halves is the same as 90 and pi is the same as 180. So we have an angle. Learned before that we always connect x-axis, and that theta should always go next to the origin. So we're drawing triangles the way that we did earlier in our trig unit. Except we aren't told how big that angle is. Before we were told how big our angle was. Here we're just given a range that allows us to draw it in a particular quadrant. Then, what the sine of this angle is. What's SOHCAHTOA for sine?
Opposite.
Opposite over hypotenuse. Given that the opposite is 3 and the hypotenuse is 5. So then we can find the third side. This one happens to be a special triangle, but in general, how could we find the third side of the triangle? The Pythagorean theorem. So we could do 3 squared plus x squared equals 5 squared. This one is 4 then, kind of. What else do I need? A negative. When we graphed before, we graphed directionally, and since this is on the left of the x-axis, that would have a negative direction attached to it. So now our triangle is labeled. We are asked to find the other 5 trig functions. So we don't need to do sine because they already gave us sine, but we need to know what cosine is. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. Cosecant is the reciprocal of sine. Secant is the reciprocal of cosine. And cotangent is the reciprocal of tangent. So we learned back a while ago about finding those 6 trig functions and drawing triangles and drawing angles and so forth. So we're coming back to these ideas here, but our information is just presented a little bit differently. Instead of being given exactly where to draw our angle, we're just given a range that will put us in a particular quadrant. Then we're given what 2 sides of the triangle are according to one trig function. We need to find the third side using the Pythagorean theorem, and then find the other 5 trig functions. Questions? Go ahead and try this next example. Quadrant do I draw the angle in?
Third.
The third, or the bottom left, between pi, which is 180, and 3 pi over 2, which is 270. Theta goes next to the origin, and we always connect to the x-axis. We're given cosine. What is SOHCAHTOA for cosine? Adjacent over hypotenuse. That negative is just kind of floating in front of the fraction. How do I know what number that negative really belongs to? The hypotenuse cannot be negative. So that 13 has to be positive, and in the picture it makes sense that our adjacent should be negative 5 because it's left, and that's a negative direction. What is the third side of the triangle going to be then? Close. Negative 12. Okay, we can do our Pythagorean theorem to find that that's 12, but directionally, since it's on the lower half, it will be negative. So then we can find our other 5 trig functions. So we need sine, which is opposite over hypotenuse. Cosine was already given. but we need tangent, which is opposite over adjacent, double negative, so cancel those out. We need cosecant, the reciprocal of sine. We need secant, the reciprocal of cosine. And we need cotangent, the reciprocal of tangent. Questions? Your homework for tonight will just be this type of problem. We are going to move forward and do more examples, but your homework for tonight will just be this type of problem, and then your homework tomorrow will include the next types of problems that we're going to look at. On your homework for tonight, remember what we have done before when we were doing pictures with triangles and the Pythagorean theorem. No decimals are allowed. Okay? If it is not a nice square root, triangle with the Pythagorean theorem, leave it as a square root, simplify that square root, and reduce your fractions. But you may leave square roots in the denominator. So just like when we did trig before, no decimals appropriate in your fractions. Simplify square roots and reduce fractions, but you may leave your square roots on the bottom. Okay? For our next type of question, we're going to be looking at the identities that are printed on your sheet. They're up here, but they look much more intimidating up here because the font messes up parentheses. Every time I have parentheses, it turns it into big B's and G's and G's and H's and K's, and I don't know why. But it doesn't like parentheses in this font. So those are printed on your sheet. You do not need to memorize any of them. They will all be provided to you on a large cheat sheet when it comes time for this test. These ones, as well as the other ones that we will encounter in the rest of the sections, because there will be more coming. You do not need to memorize any of them, but you will want to have them with you when you do your assignments for reference. You will use these in your assignments. You will use them on the test, but I will provide them for you on the test. These strategies are not written on your notes. You probably would want to write these there to remind yourself of our methods of solving. The next type of problem that we're going to look at is simplifying expressions. When we simplify an expression, we're trying to clean it up. Okay? We want it to be equivalent to what it used to be. Just like 2 over 4, we can simplify down to 1 over 2. It's the same as what it used to be. They both have the same value. It's just smaller. Same type of thing here, except these have trig in them. Our strategies. The first thing we're going to do is factor. So we learned how to factor. It's not going to happen in check that list of all of those identities that's on your sheet and see if there's any substitutions that could be made. Can I swap out something for something else that would make this problem cleaner? The third thing we're going to do is change into sines and cosines, and I will explain more about what I mean about that when it comes up in a problem. And then this is not like a one and done, go through your checklist kind of thing. After you reach the bottom of your list, try again. Now that I've done these other things, is there something now that's on my identity list that didn't used to be there? Is there some factoring that could be done now that I couldn't used to do? And continue to work on through. One of the most difficult things for students with simplifying is knowing when you're done. If you can get down to just one term, then you're definitely done. Right? One term is as good as it gets. So if you can get down to one term, that's a really good sign that you're done with the problem. If you get down to what you feel like might be the end of the problem and you have more than one term, run through the checklist again, and if you can't do any of these things, then you're done. Okay, so sometimes we can't get it all the way down to one term, but if none of these things work, then we're done. So, factoring was our first strategy. Factoring means taking out what's in common. So we did this back when we studied our quadratics earlier. So if I had like xy squared plus x, What do those have in common? What do they both have? X. When we factor, we say, let's take out what matches. And by take out, we're dividing it out of the problem. What's left over? The front of the parentheses. Y squared plus 1. We always need to make sure that we have the same number of terms as we used to have, so that if we would distribute through, we have exactly the same problem. Because remember, we don't want to change the value of this. We just want to change the way it looks. Just like 1/2 and 2/4 are really the same thing, they just look different. So we need to make sure that we could undo and distribute back and get what we started with. So we want to take out what's in common by division. So what is in common in these two terms? Secant of theta. So we're going to take that secant of theta out front, which would leave a tangent squared of theta plus 1. Because secant divided by secant would be 1. And if we would distribute back, we would end up exactly where we started. So our first strategy is to try to factor. So we were able to do that here. The second strategy is to check the identity list for anything that we might be able to substitute into this problem that would simplify it. When I see squared things and ones, I look at that first group of properties, which is called Pythagorean identities. They are called so because they actually come from solving the Pythagorean theorem. Weird ones in them. Look at that list of Pythagorean identities, and do you see anything that has a lot of the same stuff as our problem? What one might be helpful? The second one, which reads?
Secant squared of theta plus 1, equals 1 plus tangent squared.
Secant squared of theta is equal to 1 plus tangent squared of theta. This has an exact match here. 1 plus tangent squared, 1 plus tangent squared, because when we add, it doesn't matter what order we add in, right? 1 plus 2 is 2 plus 1. So we have an exact match here. So what we're going to do is say that that 1 plus tangent squared of theta is also known as a secant squared of theta, and we are going to substitute or replace it in our equation. So that secant that was on the outside is going to stay on the outside, but on the inside, that whole thing is going to be replaced with a secant squared of theta. So now I have secant times secant squared. That's kind of like x times x squared. What would that be? X cubed. So secant times secant squared would be secant cubed. That is one term, so that's a really good sign that we're done with this problem. Okay, so our strategies. First thing we do, factor out anything in common. Both of these had a secant in them, so I took that secant out front. Check the list for anything that matches where we could make a substitution. Make any replacements you can make that will help simplify the problem down further, and do algebra and arithmetic as appropriate. Good question, and I actually don't mind that question at all. The reason why you do this is not a practical you will do this in your job thing. This is a building logical reasoning skill and a building a rule following and procedure following skill. Then you try again. If at first you don't succeed, you try again. So go ahead and try this one. What's in common? Cosine of theta. So we're going to take that cosine of theta and bring it out front by division. When we do that, we get 1 minus a sine squared of theta. You must always have the same number of terms after you do your factoring, so that if I would distribute back, we get what we started with. Then the second strategy is look at the identity list for replacements. So I want to look for something that has 1 and sine squared. So again, ones and squared things, so I'm looking at that first group. Is there an identity that has a lot of the same stuff as this problem? Which Pythagorean identity has a lot of the same stuff as we see in this problem? The first one, sine squared theta plus cosine squared theta equals 1. It's got a lot of the same stuff. It's got sine squared, it's got 1, it's got the cosine. It's not exactly a perfect substitution like it was in the last problem, though. What we can do, though, is a partial replacement. So I'm going to take this 1, and I'm going to say that 1 is equal to sine squared plus cosine. And change out that 1 for sine squared plus cosine squared. It seems a little counterproductive because we're actually going to make the problem messier for a moment. But sometimes we have to do that. For example, here when I go through and clean out my closet and decide what to donate, I throw everything that is in my closet on my bed, and my room becomes a disaster. But then as I sort through, it actually becomes cleaner in the process. Okay? So sometimes we have to mess things up a little bit to get them cleaner in the end. So that 1 is going to get replaced with a sine squared theta plus cosine squared theta. Everything else is going to stay just the way it was. Now, why does that help me in the long run?
Because it gets rid of a sine squared.
Because now I have a sine squared and a minus sine squared, and they can wash each other out. Something minus itself cancels to become 0. So that leaves me with cosine of theta times cosine squared of theta, which will be what? Cosine cubed of theta. Okay? Let's try another one. This one does not have any factoring that will work for it. If we look in those parentheses, there isn't anything that matches. So that factor strategy, remember I said, was rare. It's not something that's going to happen for us every time, but it is still something that we want to look for every time. So then the next strategy is a replacement. The messy part of this is that cosine of pi halves minus x. Is that anywhere on your identity list as being something that we could substitute?
Yes.
What is cosine of pi halves minus x equal to?
Sine of x.
Sine of x. So that whole thing is going to become a sine of x instead. We are going to swap it out because our identity list says that we can. Co-function identities. It says that the cosine of pi halves minus x is equal to the sine of x. The third strategy is something we haven't done yet. It says to change into sines and cosines. Back in the first part of our trig unit, we said that tangent was equal to what in terms of sine and cosine when we did our unit circle? Y over x with a unit circle, if we're thinking about our x and y coordinates. Opposite of our adjacent in a triangle. But what about on our unit circle when we write on one of those 4 lines? How did we find it? Sine over cosine. Tangent was equal to sine divided by cosine in our unit circle from the first part of our trig unit. This problem doesn't ask about tangent, though. It asks about cotangent. Well, what is cotangent? It's the reciprocal of tangent, right? So it's going to be cosine over sine. So when we say to change into sines and cosines, what we want to do is rewrite everything in the problem just using sines or cosines. So I'm going to switch that cotangent out for a cosine over sine. Before I do that, the 2 other substitutions that could happen here, cosecant of theta is equal to what? What was it the reciprocal of? Cosecant is the reciprocal of? Sine. So cosecant will be 1 divided by sine. And secant will be what? 1 divided by cosine. Okay, because those were our reciprocal functions. So those 4 substitutions are what we're looking for when we say change into sines and cosines. Those will not be provided on your cheat sheet when it comes to the test. You need to know those. We were actually supposed to know those a long time ago in terms of the tangent being sine over cosine. So that's carrying over from the first part of this trig unit. So in this problem, we're going to take that cotangent and we're going to say cotangent is equal to cosine over sine. And sine, I'm just going to let be sine, but I'm going to put it over 1 because I like to make everything into a fraction. You don't have to do that, but I just like to have everything be fractions so it's all consistent. The goal of changing everything into sines and cosines is that ideally some cancellations will occur. What about in this problem? Sine on the top, sine on the bottom, they cancel each other out, leaving us with just cosine of x. And if you can get down to 1 term, you can be pretty confident you're done. Okay. Questions?
I don't even know how you got the sign to start off with.
The very first step, what's circled there, is able to be replaced with a sign of x according to the identities at the top of the worksheet. Under the co-function identities, it says that cosine of pi halves minus x is equal to the sine of x. So we're doing a substitution for the identity list as our first step. All right, let's try the next one together as well. There's no factoring to be done here. So first thing we look for substitutions. What about the sine of pi halves minus x? Is that on our identity? Yeah. Equal to what? Cosine of x. What about secant of negative x? The third group of identities is our negative angle identities. Is secant on there? No. It's just the big 3, sine, cosine, and tangent. So we can't make any replacements with that yet. So then our next strategy is to change into sines and cosines. 1 will be 1. Cosine will be cosine of x divided by 1. Secant will be equal to what? What is secant the reciprocal of? Cosine. So secant will be the reciprocal of cosine 1 over cosine, and since it was a negative x, it will still be a negative x. Whatever that variable is, let the variable remain the same. Now remember, it's not a one and done through that list, so then we'd want to think back, now is there anything we can do a substitution for? So that cosine of negative x is new into this problem. Is that on our identity list as something that can be substituted? What is that equal to? Just a plain cosine of x. On our identity list under the negative identities, it says that cosine of negative x is the same thing as just cosine of x. Now, algebra, to simplify this, how do I divide fractions? Multiply by the reciprocal. So I flip over that bottom fraction and do a multiplication instead. What is cosine times cosine? Cosine squared. Check for substitutions again. We've got a lot of ones and squared things, so if I check that identity list for a substitution, under the Pythagorean identities, it says that sine squared of x plus cosine squared of x is equal to 1. Or it might say it with thetas, but x's and thetas are the same thing, so you can swap them out as you want. They don't really matter which one you use. So we could do a substitution as we did before, saying that 1 is equal to sine squared plus cosine squared. Will that help us? Will anything... If I do that, I will have a sine squared plus a cosine plus another cosine. Since there's no subtraction, nothing's going to disappear by doing this, so it is not helpful to do it. So that means that this problem is actually done. So if you can get down to 1 term, you know you are finished. If you get down to 2 terms, check and see if any substitution would help you get down to 1 term, and if it won't, then this is just as good as it gets.
What was the step between where you switched to blue, green to blue?
From the green to the blue, I did the substitution of that circled part in blue. Cosine of negative x became just a plain cosine of x, according to the negative angle identities. Okay. Your homework tonight is the night 1 portion of what is printed there. It is only the first type of problem we looked at, none of the simplifying problems. Tomorrow we will work more with these identities and simplifying and verifying, and that will be on the next part of the assignment.